Yo, what's up, everybody? Welcome back. Today we are running a language model from Zig, an AI language model. Wow, fancy. We're fucking AI developers now. What can I say? Context is, sometimes I want to watch TV and I write down all of the shows that I watch for, a couple reasons. One is that I might want to write notes about the show and keep a history of what I thought about them as I was watching them. I might want to rate them according to some rating scheme that I've had. Ooh, new episode, I like it, slop for the piggies, wee. Things fall into those categories quite often. And I want to know, if I was watching a show and then a new season came out, it reminds me because it shows up on here, right? Euphoria, I heard season 3's dog shit. I say, fuck that shit, I'm not going to watch it. It disappears. Exciting. One of the things that we might also do is we might see an ad for a movie when it comes out in theaters, right? So I, at some point, saw an ad for John Wick Chapter 4 in 2023 and said, maybe I'll watch that at some point. And then when I go to watch a movie, I come to this page and I go, oh, here's all the movies that I said I wanted to watch at some point in the past. I care about when things release on DVD, not when they release in theaters. And so what should be shown here is a extra field that says when this thing was released on DVD. There should be a whole category here that's higher up on the list. The API I used to use for getting movie data used to have this information, but it was pretty inaccurate and also just stopped being added completely. There are APIs that do have this data, but they say things like, if you store this data for 6 months, then you are breaking our contracts. And I think that if I want to store data in my notebook and I want to write down the fucking date, I should be allowed to write down the fucking date, right? And so we are using Wikipedia as our movie backend now because Wikipedia doesn't have any rules against this type of thing, as far as I can tell. Creative Commons 0 license on all data. And so what we can do now is we can say, Spider-Man, I want to watch Spider-Man. And we get a list of movies from Wikipedia. We do this by kind of searching the title and then checking if the thing is a film and then extracting data from the film info box, right? So Spider-Man will have all of this information here, including release dates. What it does not have, though, is DVD release dates. It does have the information on this Wikipedia page, but not in this box on the side, right? It does usually have it. If you just scroll through this thing a lot, you usually find something that resembles this, right? So, Spider-Man Homecoming was released on digital download by Sony Pictures Home Entertainment on September 26, 2017 on Blu-ray, Blu-ray 3D, Blu-ray Ultra 3D, and DVD. I go, well, I can read that. I'm a fucking person, right? I'm a human who can read that. But if I want this data in a way where my TV tracker can extract that date and say, hey, this is ready for you to watch now, I need something a little bit more structured than that. So I trained a neural network that should be able to run maybe in the orders of 10 milliseconds per paragraph on basically, can you learn if a date that you see is related to a home release, right? So what we did is we took a really slow, shitty LLM and we said, read this page, tell me if there's any dates. And he goes, okay. And then we take those dates and we find them and we say, okay, shitty LLM, see if you can find those same dates. And you can do something relatively correctly as far as I can tell. I think we don't have Spider-Man Homecoming page downloaded, but we do have Spider-Man 2's page downloaded. And I think in Spider-Man 2, if we go scroll around, there's a home media section where he says November 30th, 2024. And if we run our little guy, we should be able to see. Oh, we did this before. Yeah. So he says, I found in this paragraph, November 30th, 2004, November 17th, November 6th, 26th. So November 30th, 2004, then November 17th, November 26th. Good. Those are all good. And then he says another 2005, October, and 2007. So there might have been extra releases in 2005. Maybe, or maybe this thing is confused. So this is in the same paragraph. So can we go back? Where was this? This is home media. Are there okay, here we go. Yep. So the film was also released on UMD format in 2005, right? So that's this. Then he says, somewhere again in October. The film was released in October 2007, which he has accidentally split as two separate instances. But, I mean, we're getting, somewhat close to something that works. So the goal for today is to take this, neural network that we've trained and put it, in an application where we can use it, right? We have this program that like searches movies. We need to like load the model in this program and like maybe do some like application programming to say like, actually that's what this should say application programming. Like to basically say I have like this list of stuff, like how do I resolve this, right? So probably it's something like, well, if they saw November 30, 2004, and then they say November 17th and November 26th, these guys are probably like in the same area, the same year as this one. Probably we want to take the earliest like year, month, day of everything that we ever see. This might be the first LLM written in SIG. Well, it's not an LLM written in SIG. We'll be clear. This is not an LLM. It's a small language model, probably. It has been trained in Python, with PyTorch, as like everyone does, and we are just trying to like consume that thing in Zig and prep our data for it in Zig so that we can run it as part of our application. So yeah, that's the plan. There's this like thing called onnx, I think onnx. I didn't really do much reading, so maybe people are gonna say this is like a bad format or whatever. But like in reality, all like a language model really is, or like any like neural network, I should say at all, is like it's kind of just like a list of operations, right? You say like I have some input, and I want you to like matrix multiply. And really like usually things are like fuse, multiply, matmul plus addition, right? So it's usually like FMA, they call this, fuse, multiply, add, and it's usually some sort of like sequences of fuse, multiply, add, maybe like attention, right? Maybe like a few like ReLUs or stuff like that, right? There might be some sort of like there's some like small-ish set of known operations where doing these operations is relatively expensive, but like the piping of things between them is not, right? So one thing that you can do if you want to like specify a bunch of mathematical operations in code is you can write a file, right? Like math Zig, and I can say like pub function, take in like, you know, do math, take in A, take in B, and then like return a thing and return like A plus B times C plus times A or something, right? Like this is the thing you can do. But another way you could define this is you could like make a data file that says like I have a list of operations, right? And these operations are gonna be maybe like operation is a union, maybe, right? You can define something like this where you say, okay, I want to add, add A and B, right? Something like this, right? And you can define operations like this. You could like put those operations into a file as a sequence and then load those files and like deconstruct the operations later, right? This is like really shitty in terms of performance, usually, right? However, in the case of these like neural networks, the piping of data is such a small part of the overall compute. This is like actually a fine strategy, right? Because what you actually are doing is you're not adding two numbers, you're adding like two blocks of like big ass fucking numbers together. And so doing a little bit of work, extra work to be like, I'm gonna do the piping here in like a slow manner is like fine. And maybe like I wouldn't be surprised if some of these like super high performance neural network runtimes or whatever did something like a JIT, right? Where they say like, okay, like I can actually take this graph and I can compile it into machine code on the fly. They might do that. I don't know. And also, you know, a lot of these times things are running on GPUs, which GPUs are jitting all the time anyways, right? When you open like your game and you have to wait 30 minutes to do shader compilation, that's like your game saying, I have some code I want to run on the GPU and I need to compile it for your GPU right now, right? So all of these things kind of make it so that this makes sense, right? So what we're going to do is we're going to export our thing that we trained as an onnx model. This is like basically, as far as I understand it, which could be wrong, as far as I understand it, it's basically like a big config file for how you run a model that is like interpreted from many, it's like a standard, right? A standard config file with a bunch of data inside it. Export the thing into onnx, figure out how to use onnx from Zig, try to use our make sure that our data processing path kind of creates the correct inputs for this model and like insert them, make sure that we get the right dates, and then maybe do some application programming to figure out turn this like list of returned dates into like one number that we can use, or maybe a range of numbers, maybe. So let's start by exporting our little onnx model config or whatever the fuck you want to call it. I don't really know. But I think we should be able to go, like, I guess this is like a new thing, probably, export. And this is probably like somewhat similar to running the model, right, in some way, but it's probably doing something different, right? So can we say, we want to load something. We have some checkpoint, some base model we're working off. We're not going to run it on anything. We don't have to, like, I don't think we want a device argument, I don't think. Precision still seems relevant. Like, we want to export, maybe we want to, like, take the floating point numbers that this thing had, kind of, like, shove them into some smaller int 8s so that they will, like, run on CPU faster, but at the, you know, at the cost of doing the right thing, right? But that's okay, you know? Maybe it works fine. This is boring. Okay, so somewhere we, like, load the model. Let's do that. And then can we just, like, how do you export this thing? Torch, export to onnx. I think in order to do the export, I think you have to run it. Because I think a lot of the way that the data is stitched in Python, like, you have to run the Python to create the stitching. Maybe. I'm not sure. Maybe the, like, PyTorch graph is, like, smart enough to know this, but I don't actually know. So when you, yeah, right, so they have example inputs here, right? So they say, like, run this thing, and here is a set of inputs. They don't have to be, like, correct inputs in any way. They just have to be inputs that will trigger the path of code in Python that you want to run. And it'll kind of, like, write down, like, oh, I saw this, I saw this, I saw this, I saw this, and then, like, put that in the config. Something like that. So I think we have somewhere, actually, where we make dummy inputs as part of training in order to, like, basically, like, calculate a batch size. Yeah, here we go. I wonder, so the inputs to this thing is like a batch of tokens. How do I say this? Like, we say, here is an arbitrarily sized tensor of token indexes. Right? I think it's, like, something like this. And so I don't know if we say, like, here are 300 tokens, if the onnx export will expect us to always give it 300. You know what I mean? Like, we want something where one of these dimensions is variable. So this is, I'm a little bit unsure here. They might be able to, you might be able to get clever where, like, maybe the most outside dimension of this thing is fine. Maybe? We should double check that. I don't even know how to check that. Is this going to ask the idiot type of angle? Or maybe we could read the documentation for onnx export. That seems like a better thing to do. Okay. The exporter tries the following strategies to get an exported program for conversion to onnx. If the model is already an exported program, it will be used as is. Use torch export export and set strict false. Use torch export export, set strict 2. What the fuck is strict? When disabled, the export function will trace the program through Python runtime, which by itself will not validate some of the implicit assumptions baked into the graph. It will validate most critical assumptions like shape safety. When enabled, the export function will trace through torch dynamo, which will ensure the soundness of the resulting graph. Oh, sure. Okay. I don't really know what that means, but sure, whatever. Okay. So, dynamic shapes. This is what I'm looking for. A dictionary or a tuple of dynamic shapes from model inputs. This is used when dynamo is true. Okay, what does this mean? This is probably what I'm looking for. Where the types should either be 1, a dict of argument names of f for their dynamic shape specifications. 2, a tuple that specifies dynamic shape specifications for each input in original order. If you are specifying dynamism on keyword args, you want to pass them in order that is defined. Okay. I don't want to click this. Yeah, so I think this is what I'm looking for. Now, the dynamic shape of a tensor can be specified either 1, a dict from a dynamic dimension indices to dim types where it is not required to include static dimension indices in this dict. But when they should be mapped to none. Okay, so it seems like if we're just giving our model, like, a bunch of, like, a sequence of indexes, I think is, like, what I expect to go into this thing. Maybe wrapped in, like, a batch, maybe. Then maybe we want to put dynamic shapes on those inputs. Maybe. The corn, 1896, thank you for the prime. Much appreciated. So, this thing says, give me, like, when we're running this for batch sizing, we say, take the max length, give me basically ones for 1 by max length, I guess is what that is. Torch ones. I assume that you are giving it, yeah, multiple parameters, which are the dimensions, right? So the dimensions of this thing is going to be like 1 by 512. Or, yeah. Yeah, 1, 512, and that's it. Okay, so can we try, when we try to trace this thing, I guess we want to do, like, model. Well, let's just try running it first, actually, with random inputs, just to make sure that we understand, right? If we run this thing, it should work. I think you just do this. Maybe you type forward. We could just try this and see what happens. Python 3, export py help. Okay, so let's do model is, what do we call this? Mini LM, no UTF-8. No, that's checkpoint. Model is, we trained this thing based off of this guy, which is a shitty copy paste. Fuck. Okay, precision, we probably want int 8 because we want to run this thing on CPU. We don't want to force GPUs on people running our thing. And now he's mad that, like, device. Can we just use default here? Can we, okay, we'll just say CPU then. Fucking hard-code it. I don't give a shit. I don't give a shit! Okay, checkpoint path is not defined. Hello? Oh, because I guess they want, like, args checkpoint here, and then args model, and args precision or something. Probably something like that. Okay, forward required 2 positional arguments. Perfect. Perfect. So we should be able to do, like, torch rand 1 by 512 of longs, I think, is the inputs to this thing. And then I think the mask is ones. So this should be IDs and mask. And this should, like, give us an output. You know what I mean? Like, if this gives us something, then we like, at least understand how to run this bad boy. Uniform bounds not implemented for long. What does that mean? Can I do torch ones? just put ones in there. Fuck it, I don't care. Okay. So that ran, right? So can we also, like, I think there's a way to be, like, in training mode or not training mode. I think maybe it's just you do no gradients. But I want to just double check. Yeah, they just do with torch no grad, which I think is, like, probably good enough. And then you don't have to type forward here. You can just do this. Beautiful. Okay, and then it looks like the output here is actually, like, we want, this model, like, produces multiple outputs that we want to look at, which is a little confusing. And I don't know how the exporter is going to know which outputs we care about. So we're gonna have to take a look at that. But let's just try running the export and just see what fucking happens. You know what I mean? Let's just see what happens. We have example inputs. It looks like you need to pass the inputs here, which is a little confusing because, like, this, I guess you just have a list of 2. We have 2 arguments, so I guess we pass this an array of 2 things. Maybe they want like a, we'll see. And they don't do like a no grad or anything. Because maybe like the onnx exporter knows if it wants gradients or not. So torch onnx export. We have our model. We have example inputs, which is going to be ID's mask. And then we'll just pipe this because they have that in their example. Okay. No module named onnx script. So we're missing some dependencies, huh? We're missing some dependencies. Nix package search. Onnx script. Okay, cool. Python 3 packages, onnx script. All right, if you say so. JJ, thank you for the prime. Much appreciated. He doesn't like that. Did I type it wrong? Onnx script. Oh, I spelled packages wrong. Yep, that'll do it. That'll do it. Becoming a Pythonista, you know it, baby. All right. Export. Okay. He is not happy here. Modify the model for this to succeed. What is it not like? Does not have a field with name obj flatten. Huh. Okay. So now what the fuck do we do? This was kind of the entire plan. Well, he doesn't like this. So there's so he's probably like walking the hierarchy of the model. I think if I print the model, if we like do like print model, I think that this will print kind of like the graph of nodes in this thing. And then we can kind of figure out where linear packed params is coming from. You know what I mean? I guess we're kind of seeing like, how do I say this? Maybe it's because we're trying to export with int8. Could be, right? He's talking about like packed parameters. Maybe that's related. So let's try without quantizing, and then maybe you quantize after. Yes. Okay. So maybe we have to quantize. Like surely onnx can also quantize its own execution graph. Surely, right? Evaluation failed. Cannot reshape array of size 1 into shape there. So that's a little scary. That's a little scary. And what like does this make? Do we have to save this somewhere? You deep dive into rabbit holes just to solve this minor problem. Yeah, this is a very minor problem. I'll say it. I'll say it. Okay, how do I save it then? Here, I type save. Okay. Program save. And can I like print like what is this thing? You know what I mean? What are we fucking looking at? Does it give us like metadata about it? Okay. Interesting. So he's like kind of like actually telling us like the entire list of things that we saw from all of Python and how they mapped to individual things. That's interesting. Okay, where does it like tell me the inputs and outputs the program that we just made? Because surely it should only be a couple things, right? Model. Graph. Inputs. So this I don't like, right? Because here he's saying these are 1 by 512 inputs, which is not really what I want. The outputs of this thing are kind of correct, right? So this is the first output here is basically whether or not each token that we input is within a date range or not. And then this is whether or not it's a theatrical or home release. So this is correct. This I don't like. This I don't like. So where we saw somewhere that we might want to say, give me, like, they're dynamic, bro. Bro, they're fucking dynamic. And where did we see that? Dynamic shapes here. Which was also, so this is on Torch export, but we also saw that that was on onnx export as well, I think. Torch onnx export, we clicked here, and then he had dynamic shapes here. So here, one of the things we could say is dynamic shapes. And I guess this is per thing. So a dictionary or a tuple of dynamic shapes, refer to this. Dynamic shapes. Okay. So can be specified as a dict of dimension indices to dim types. So I think it's like we have a tuple here, right? And the first one is IDs, the second one is mask. And the dimensions, like these, we want to say only the second dimension of this thing is variable, right? The like outer dimension of 1 is not. Also, can we run this thing? Also, like, do we need the batch? Maybe we want the batch. We might want the batch because we might want to run all the paragraphs in parallel. So maybe that's good. But okay, what happens? Can I run this thing if I just do give me ones in the shape of 512? Is that a thing we can do? Let's just double check. Because it might let us. If it doesn't, then like fuck it, but I just want to try this first. You know? Yeah, okay, so he really wants those ones. That's fine. Which means that here we want to say the dynamic shapes are to their dynamic shape specifications. The dynamic shape of a tensor argument can be specified as a dict from dimension indices to dim types, where the dim types correspond to the dynamic dimensions. And the static dimensions are denoted by none. So I would guess this is none dim. That's like what I would guess from what I'm reading, but it's like very unclear to me. So I expect this is not correct, but that's what I would guess. And then what the fuck is dim? Where does dim come from? Like, hello? Oh, dim. Oh, wait, what's this? Dim equals dim. What the fuck? This example means the generated code requires dimension 0 of input x to be less than or equal to 5. Jesus Christ. Torch, export, dim, dynamic. Can we just fucking find an example? Dude. When you're like looking up AI stuff, you see so much dog shit like this. Like, maybe this will have the answer, right? But like, I think that anybody who is like writing something that says mastering dynamic tensors, it's like if you were like, you're a fucking expert in counting. It's like, you know what I mean? It's like, we're not fucking talking about something complicated, right? I don't think. Like, the idea that there is a master of dynamic tensors is such like an insane thing for me to to put into words. Like, at all, you know what I mean? It feels like so like fucking condescending. Like, fuck you, you know? I'm still gonna click it because I want to know the answer, but like, go fuck yourself. You guys want to see some like weird fucking AI toenails? The problem is that a human didn't read that before publishing. Maybe, but I feel like I like experience this in the real world as well, where like someone will say like, this guy is the expert on blank, but blank is like such like a basic topic that it's like kind of like upsetting to me that they say it at all. Okay, dynamic shapes, they are using a dictionary of input names to this. Okay. So export dynamic shapes dim. But like this, why does this have a name? I guess they're kind of saying that we get to define the name of this thing, maybe? So maybe we're kind of saying like, maybe we're kind of saying something like tokens here, right? Like this. And then I guess they're kind of saying like, here we want a dictionary on each of these layers of the argument of the index. So index 0 is none, and index 1 is our dynamic batch dim. Maybe something like this. You know what I mean? 0, none, because we were saying we're always going to do one batch, but 1 is going to be dynamic batch dim. And then here we need to specify the maximum size. So we can say 512 here, I think was what they said in the other fucking thing that we were looking at. Yeah, here you can say max. So we say max is 512 because we know it's the maximum things that you can feed per batch. I think that makes sense. And then does this just work? Maybe. Okay. So he's not angry. He like ran through the whole thing, which is a good sign. And then can we I guess scrolling is the inputs. Fuck. I don't want. It's too much. Okay. Ah. Nice. This is perfect, right? So now we're seeing that we have a batch of size 1 with tokens as our input. And then here we have tokens again. And then here we have our output is 1 by tokens by 3. Is tokens defined in here anywhere? Like, as like, what the maximum is? Or is it just kind of like propagated through the chain? And you know what? Maybe we do. I wonder if it's fine to have like a batch argument. Like, fuck it. You know what I mean? Like, okay, this should be a tokens dim is what you call this, and this should be called batch dim. Fuck it. You know what I mean? Fucking go crazy. I don't give a shit. Who am I? Who am I to tell you what you can and can't do? They call me a Tensor Pro. Like, fuck it, you know? Fuck it. Okay. Oh, he doesn't like that. Why? Because I should have called it batch dim, not batch. This myopa is a thing in other domains too. Lack of curiosity and thinking tech is completely defined by their own, often new favorite thing. I agree that it has a very distinct smell of inexperience, but I don't have a good word for it either. Yeah. Okay, I see what you're saying. Yeah. I'm glad to know that I'm not the only one. What is this thing? Okay, some sort of binary format. But that also has a lot of text in there, which is kind of funny. Surely this is not like a good. Oh, see, it's not. I'm sorry. Hex dump. Like, surely this is a non-stripped version of this thing. Can we like, can we strip this? Like the equivalent of running strip on a binary? Because whatever's in there is like too much. You know what I mean? Export params, artifacts, verify, report, whether to save model weights an external data file. Like, you know what I mean? Like, there's something in here. There's just too much stuff. There's too much stuff in there. Training, operator export, do constant folding. Like, how big is this thing? 87 megabytes? I guess that is like about how big the weights are. Maybe I'm being like a little picky. But it's like, you know, like surely like call function torch ops is like not a useful thing in there, right? Like this has to be like a list of things that it did as it was exporting. Maybe these are warnings or something, but like what the fuck? You know what I mean? You know what I mean? Can we say like reduce onnx export metadata? You know what I mean? Um, inside the onnx model, there are so many files that I don't want. Yeah, right. Like this is kind of what I. Well. Yeah. Yeah, okay. Do you have an idea? Maybe at this guy and then just nobody answers? It's like, yeah, that makes sense. That's the idiot. When I export an onnx model, there's so much like Python source text or like debug output. It's just like fucking nvim this thing. It's like, what the fuck is this? How do I tell it to ignore? Bloat Central. Was that onnx format or Python pickle? Oh, yeah, maybe. Oh, no, I think I did type save. He's like, make sure that, okay, disable this stuff, rerun your export. That's funny. That's kind of funny. I'm not, yeah, you're right. I'm not like just pickling this thing, right? I don't think so. Right, because I'm typing program.save model.onnx. So surely, if I type .save here, like surely it should do the right thing. But we should also probably look at like the arguments to save, right? Because he told us to type save. But like, you know, you never, like, let's look at the API arguments here. Include initializers. Okay. I think we want initializers. That seems, well, it depends what initializers mean. If this means like, hey, I want you to initialize weights with these parameters, that's what I want. But if it's like, I don't know what initializer even means in this context. Model weights. Yeah, so we want those. That seems good. Yeah, nothing in here is jumping out. What did this idiot say? He said try these environment variables, which is very funny. Don't I want Dynamo though? What did we say Dynamo was? They said to have. They said they turned it on by default at least. Dynamo. Dynamo. I guess we read the API docs again. I can't remember what the hell that thing is. Dynamo. Enables new onnx export logic, which is based off of Torch export program, a more modern set. Yeah, so that seems good. So shouldn't I not disable that? I wonder what the idiot's talking about. I like the idea. Yeah, I don't trust him. I don't trust him. None of this sounds reasonable. You never know, but if you're using these paths often emit a ton of logs. Make sure you aren't pressing verbose is true or aren't enabling a debug thing. So is there like verbose? Whether to enable verbose logging. Like, can I just say verbose equals false? Maybe it's on by default. How can I fucking tell? How can I tell? We'd have to go into the source code, I guess, because Python. But we can just say maybe in this list of things, can we just say verbose is false manually? Like, please shut the fuck up. You know what I mean? I would like you to shut the fuck up, please. Thank you. And then can we not print the thing at the end so that I can actually see what this thing's talking about? Okay. I mean, that's still a lot of text. like, why is there a Torch onnx stack trace? Am I crazy? Am I crazy? That seems insane. I don't think that we should have stack traces in our output. Like, am I fucking high? Okay, what else does this guy say? I mean, maybe we should listen to him because we did ask him. Yeah, there is a lot of debug metadata and stack traces. To stop it, you need to reduce export logging or disable. Maybe I just ignore this. Maybe I just don't give a fuck. Disable stack trace in onnx export torch. Like, what the fuck is going on? Stack trace. During onnx export, the onnx node is annotated with metadata that helps trace its origin and context from the user's project. I don't want it. This useful is info for debugging models, but I don't want it. I don't want it. Turn it the fuck off. Turn it off. like, hello? I don't want it. I don't want it. Shut the fuck up, you know? Oh, metadata props? Wait. The overall onnx graph has the following metadata. Can I just like strip onnx metadata? Is that like a thing we can do? You know what I mean? I just want it, I want it gone. Onnx script, onnx torch stack trace metadata. Remove Python stack trace from onnx export. Like, I can't be the only person who's had this question, right? Like, surely? Surely. Like, surely. Namespace. I can't be. Oh, wait. Each output value in the onnx graph may have the following metadata property. Oh, wait. This is not like a turn off, though. Can I, is there a metadata like in the fucking like API reference? No, nothing in here says anything about metadata. Python model, args, quarks, verbose. We tried setting up the false. Input names, output names, version, dynamo, external data, which is just about word put weights. Dynamic shapes, we already put that. Translation table, I don't want that. Whether or not to make a markdown report. I mean, is that, they're not fucking dumping a markdown report inside the fucking model, surely. Surely. Whether to profile process, whether to verify, whether to optimize. Export params. We do want weights. Dude, I feel like fucking high. I feel fucking high. I guess I just, oh, there's more down here. Wait, hold on. Deprecated. I feel like fucking insane. I feel insane. But I guess I just ignore it. I guess, because, like, we need to make progress. But, like, what the fuck? Never look at the stuff that you made, okay? Never look. Torch onnx export. So then they somewhere tell us how to load this thing, right? So you can load it back into thing. Run onnx. So they're like, just fucking rip this stuff. Okay. What does this do? It's okay. Now what? onnx model. Can I do like, can I run it with like torch tensors? Let's do like ones. Give me 300 ones, you know? IDs. And what was the other thing? IDs and mask, which is also ones. It has to be the same length. IDs mask? Like, does this work? Does this do something? I don't know. Model proto object is not callable. Okay, so how do I run it? Oh, here. So they say, we'll just copy paste this. We'll copy paste this. I'm not above it. Where are my example inputs? What, like, surely he's missing stuff here, but that's okay. I guess we said this. Example inputs is, ignore this. Import torch or something. So here they're looking for key value names, I guess. What is provider? CPU execution. Sure, that seems reasonable. So much onnx, yeah, so much. True. I don't really believe that this thing needs a dictionary. I'm just like going by my gut and feeling like we don't. Can we just look at like what is this thing? Inference session. onnx inference session. Let's just look at the auth docs. Python. Like, what is this thing? Did I forget an E? Inference. Inference session. All right. Are you telling me that? Oh, here we go. Here. Perfect. Run. Output names. Name of the outputs. Input feeds. Dictionary. Input name, input values. Okay, so he does need input names. So do we have input names anywhere? Like, when we exported this thing, did our inputs have names? It didn't feel like they did. Right? Like, they were just, oh, input IDs and attention mask. I guess they do. I just found them from the Python names. That's crazy. Dude, Python people are crazy. People are fucking crazy. And then, what is like input value here? Can it be like a torch tensor, or does it have to be a numpy tensor, or what? Whatever. So this is gonna be input IDs is IDs, and then we're gonna do input or attention mask. Okay, and then we should be able to be like torch ones, I would assume. Right? I assume that we should be able to like 300 inputs of ones. D type is torch long, maybe? You know, let's just see if that does something. No field name onnx runtime. Fuck me. Surely, it's just called onnx runtime, right? Surely. Maybe we can search it while we try the first time. onnx runtime. Oh, yep, he did like that. All right. Input must be a list of dictionaries or a single numpy array for input attention. I see. He's like very all in on numpy. Which means that we need numpy in here. Python 3 packages numpy. All right. So import numpy. And surely that's just the same API, right? Surely with type numpy long? Surely, right? Fuck. Numpy ones. Shape. He wants shape as a single argument, not as a bunch of arguments. Makes sense. And then does he have a D type argument here? Yeah. Sure. Let's try that. Oh, good news. Boom, baby. So we should see like, if we want to see the first token's 0th output. No. Okay, what is, oopsies. So this should be like, the first token's 0th output is the classification for each type, right? So this is saying that it thinks that the first token is, this would be like not a date, start of a date, inside a date. And so like the most likely of these three is not a date, which makes sense. And then if we look at like the second thing, we should see basically like two options. Oh, right. Sorry. Whoa, that's not what I expected. I expected this next argument to have like less things in it. Is it because they put a 0 on this? Yeah, maybe 1 is the other output. Okay. Okay. So this is the like I don't know what we called it. It was like the BIOs, I guess, is what we saw it. And then this, I guess this is like result is this. BIOs is result 0. And then the classifications are result 1. And so we kind of go token by token. I guess both of these we know we're running a single batch, right? So we kind of can pull out the first batch of these things. And then these guys will have like classifications shape. Results, sorry. Yeah, okay. So then we go token by token, check this, then check this if it's in a state that makes sense. Okay, that makes sense. That makes sense. So we can iterate by token, get its date classification, and then it's like home or theatrical release classification. Perfect. Understood. So we understand this from like a Python perspective. I would say that holy fuck, we spent 40 minutes typing export. That's crazy. I don't even know how that's possible. But we managed it. So we have this thing. Can we run it from the C API? onnx runtime C API. This is like a thing that exists. Get started. So basically, we just want to do the same things that we did here, right? Where we like start an inference model thing. Okay, load onnx model C example. I don't really give a fuck about reading docs until we have an example to go with it. Just give me some fucking code. Give me some code. Somewhere. onnx runtime C example. Beautiful. Alright, what the fuck is this guy doing? He's got... where's main? Main. So there's a ORT, onnx runtime. There's an environment, a session, an allocator. That's crazy. Memory info. Values. And then where's like the model? Which one of these things is the model? He like loads this with the model path. Oops, I don't know what the fuck just happened. I double clicked something and like because I highlighted something, it just jumped me somewhere. Fuck off, GitHub. Okay. So here he calls create session with an environment and a model path. So I guess a session is a model, would be my guess, right? And then when he runs the thing, he probably just runs it through the session, right? So here he creates tensors with Gort. Who's Gort? Is Gort get API? Okay, interesting. So Gort is, I guess because like they might have to support multiple APIs and stuff. Sure. So we get a Gort. We create an environment, session options, number of threads, graph optimization level, execution mode, all of this. All of this makes sense. Create a session, and the session is the model, right? So we're expecting somewhere when he runs a thing, he's using Gort to create a tensor, then calling Gort run on the session with the tensors here. And then output tensor is just a guy that's living on the stack here. And then we like iterate that thing somehow. Gort dat onks burr is like, that's like a sentence that is only said in this chat. I feel like this is like a unique thing to exist on the internet. Gort dat onks burr. Hell yeah, baby. Hell yeah. Okay. Sure, fuck it. Does let's just fucking start typing maybe? Yeah, let's just start typing. Run model.zig. So somehow we need to like get onnx bindings. Do we still have C import, or has that been destroyed? Looks like it still exists. C include onnx runtime. Is that where this came from? What did that guy do in our example? Include onnx runtime C API. Sure. Build Zig. Let's make a fucking executable, baby. Run model. Boom, 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 boom. All right. Run model. Return error. No, just as a way to like test this is working. Good. Okay. C dot. I guess probably we don't have this thing installed. One more level of Nix shells deep. onnx runtime. Surely that's good enough. Surely. All right. Run model. Gort is C onnx. Okay, that's good. ORT. What was it? ORT something. Then he dereferenced it and called get API. Get API base. Get API. And here we're like API version. Okay. And then we're like Gort. Like, what is this thing? Does this work? Make. C import failed. libc headers. Sure, I guess we do need to build against libc. Run model link libc. You are allowed. You are allowed to link libc. I allow it. C import failed. Why? Onnx runtime C API not found. Fuck me. And grep onnx. All right, what do we have here? Onnx runtime here. I guess those are not the development packages though. That is only the library here. This is what I'm looking for though. This should definitely be there, right? Unless this. Yeah, that's a little concerning. Did I spell this wrong? Wait, I mean, it's interesting that the autocomplete is working. Right? The autocomplete is working. So it's a bug in like how I've set up my build, maybe? Maybe I can't build in debug with this? Maybe I need to like use LLVM. I don't know. We'll try that. No? Maybe I'm supposed to do a translate C on this thing. onnx is translate C. Root source file is B path onnx H or something. And then here we just do include onnx. What was it? we'll try this, because sometimes, you know, he wants to be like this. Sometimes. And so we can be like, run model root module, add import onnx or something. He doesn't like this because target needs to give me a target. And he actually needs an optimize. Interesting. Okay, here he's mad because maybe we need to turn this into a module. Okay, and then here, he's just saying the same fucking shit. Because I put quotes in here like a fucking dumbass. There we go. onnx runtime CPI not found. I mean, he's saying the same shit. Saying the same shit, which is annoying. Maybe because I don't have it in my, like, Nix flags for some reason. I mean, it's right here. This is usually enough. I'm quite confused. I'm quite confused because he usually respects this. Maybe I don't have package config? Maybe I need to, like, depend on this library in some way? Maybe? That doesn't sound right. But, like, maybe. Because I guess package config might pull it in usually? It's possible. Interesting. Interesting. So maybe he's not really respecting the Nix C flags, but he does know how to get the arguments from package config. And so I need to specify, hey, like, look for this thing. Okay. So now I have to say, like, no, don't worry about it. You are allowed to dereference this thing. Expected optional type. Oh, is it this way? Back to Gording. So true. Cannot call optional type. Am I fucking stupid? API base is this. Oh, hold on. This would also be now, like this, because we have this guy somewhere. Yeah, we have it like this. Okay. C get API base. Oh, maybe it's like this? Maybe. Does not support field access. Like this? There we go. Holy fuck. Okay, so we got Gort now. We got Gort, and then we want to do, like, Gort. Maybe we need to do this again. Create. Env. Okay. So here we are putting this env somewhere. Do we even need it? We do, because to create a session, we need the env. Oh, this is interesting. Interesting. So all of these, like, setters on these are probably all, like, opaque structures. Interesting. And then we also need to, like, check these things. Check, C check, we'll call it. Who takes in, probably these are, like, CNs, right? Yeah, it's probably, like, if res is not equal 0. Probably. You know, probably something like this. I meant to put capital G, but capital O is much funnier, so we'll leave it like that for now. This should be a function. Alright, so we are trying to create an env. So we have var env is like a C or TM, probably, equals undefined. Is he a pointer or what? He's a pointer, and he's passing double pointer here. So we want one of these, and so we can kind of say he's null. And we can pass him here. with whatever the fuck he wants here. ORT warning level, and then what is the argument here? Log severity level, log ID, or Gort. All right. So we should be able to be like, this should be env opt maybe, and then we have like const env is env opt, or else return error. But in reality, this environment is always just going to other places, so we can just kind of keep them as is. I think that's fine. I guess fuck it. All of these are C-check now. Boom, 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 boom. His Gort gets replaced by Gort, and then all of these are just dots, I think. Cool. We need a session options. Session options, which is surely just like a pointer to see ORT session options or something. Right, something like this. Then we do this stuff. This is like this is like this. Model path is model onnx like this. Session does not exist yet, but surely this is just an ORT session, right? Surely these are all the same, right? You know what I mean? CPU memory info. So he is defining an allocator. Do we have to do this? Or can we just kind of like use a default? You know what I mean? He's like telling us how to create allocators with memory info here. An allocator? Oh, interesting. Maybe this is making, like, it sounds like maybe you would have, like, a CUDA allocator, which is maybe different than, like, a CPU allocator. So maybe we're kind of saying, like, go crazy, like, here, just construct a default allocator for us or something like that. Is all of this, like, necessary? This feels, like, kind of crazy, no? Let's just, like, as an alternative, can you give me an example C application that runs a model onnx with onnx runtime C API? I just want to see if he does like all of the same stuff here. Yeah, so he's getting Gort. He's creating an environment with some sessions. All this makes sense. But then he's skipping a lot of the other stuff here, right? Like he just uses the default session options, which I think is sane. That makes more sense to me. Here we know what the number of inputs is, so we don't have to validate. I mean, somebody could lie, but fuck it. And we know the names as well, so we don't really have to do this, I don't think. Because we should just be able to define it ourselves. Yeah, okay. So let's just kind of use the default session options. I like that. Let's not, like, he's not making an allocator either, right? Which, oh, he is down here. Interesting. He chose arena allocator. This guy chose device allocator, which is interesting. I don't know what that means. onnx runtime create CPU memory info. Like, what does this fucking thing do? Create CPU memory info. All right. Create an ORT memory info for CPU memory. Type. Okay, well, what are my types? ORT allocator type. We got device arena, read only or invalid. Okay, well, can we get some information? Fuck me, I guess. What does it mean? I don't know what I was expecting there. Okay, could you fuck off, GitHub? Like, what in the actual fuck? What in the actual fuck is this? What is this? Right? Like, I open a page, GitHub, do you think that this is a reasonable thing to show me when I'm trying to fucking look at the source code for something? Like, it's literally like, what, 25% of all pixels is like part of the useful information? Like, what are we talking about? Holy shit. Oh my god. Not even defined in here. Fuck off. Okay. Like, ORT allocator reference. Like, I could make a guess as to what those types are, but it seems crazy to me that there's no like explanation. You know what I mean? Was it ORT device allocator? Yeah, it was, I think. I would assume that dude, can you fuck off? I wonder if it's like in the header, maybe it gives us a little bit more information. Arenas for CPU and on-device allocators for GPU, but it says creates CPU memory info, which makes me think that it's creating it for consumption, for like, you know, CPU memory consumption. I would assume, but you're right. There is maybe an idea that it could be the other way. Like device could mean specifically GPU device. I assume this meant like device that I'm running the model on. Docs are just auto-generated from header. Yeah, I would like to look at the header though, just in case. So we have, was it device allocator? Fuck. Yeah, what more could I hope for? You know what I mean? I'm just going to assume that device allocator has to be freed and arena doesn't. That's gonna be my like guess here, but this is like an insane. This is insane, but I guess like whatever. Fuck it. You know, we could look at the source code. I don't care enough. Mem type, we got CPU, default. Yeah, default's fine. And then we need memory info, which is sure like a ORT memory info. Yeah. Surely. And then we need an allocator. Alright. Let's do a little. Ooh. These things do not return C ints like every other C program that's ever been used. Where's our like example that we were copying from on GitHub somewhere? I see. I see. So we are looking for, first of all, let's shove Gord up here, you know? Just ORT API base, probably, right? Yeah. And then we go Gord like this. Oh no, Gort is not the API, that's ORT API. There we go. Okay, so then in here we can do what they were doing, which is essentially they get a res of C ORT status, and then he needs to say if we say res status is res or else return, then we return error Gort. Fuck off. All this for some movies. Hell yeah. Then they have like Gort get error message, Gort release status. But I think we're just gonna do like Gort release status. I guess we want Gort to be this just so he's a little nicer to use. Status. You expected one of these, found one of those. Okay. Okay. Create. All of these guys need to put little dot question marks everywhere because function pointers in C could be null. We have to say, no, don't worry about it. Don't worry about it. We know that shit's there, baby. And then all of these need to be tried. So true. There we go. Easy. Easy peasy. Could you use some metaprogramming or wrap the standard C functions to return Zig errors? I don't want to. But, like, probably. That's, like, a thing that you could do. Does it work? Yes. Okay, that's a good sign. It's a good sign. So how the fuck do we run it now? We need to, like, make a tensor, right? So, we know that these things are going to be, like, longs. We know that they're going to be ones for our test. So let's, like, make a fucking tensor. How do we make a fucking tensor? I don't know. They are creating, I guess, a single ORT value is the tensor. So we can create tensor with data as ORT value. Perfect. Is that what the idiot does as well? Create tensor with data as ORT value. Yep. All right. What are you doing? Yeah. I know, man. IDs, I guess, is a pointer to ORT value. Maybe this can be null. We are basically trying to run a neural network that we trained in Zig, from Zig, I guess, because that's the context of the application that we want the model to run in. We're just trying to figure out how the fuck does onnx work. I don't know. I don't fucking know, you know? Port the Gort. Yeah. We gotta port the Gort. What is input data here? I guess this is the thing that we're trying to make, right? So we have, like, tokenized text here. So here, I guess we're gonna have, how do they, like, is input data just like a flat buffer? Probably, right? Total elms. Yeah, input data looks like he just malked some shit. Yeah. So we're kind of like assuming, I guess, that we have, like, if we have a 1 by 300 array of input IDs, I guess if you have like 2 by 300, I would assume that the 300 for the first batch come first and the 300 for the second batch come second. I would assume. So let's say, like, here we have, like, token count is 300, and let's just say we have, like, an array of 300 of token count use 32s, maybe splat 1. I wonder if this is going to be the wrong type, because they wanted longs, which makes me feel like it's going to be U64. What is, like, a torch long? Yeah, great. Int 64. There we go. Oh, so not U long. So he wants I64s here, I guess. IDs, data. All right. You're in and see. We wrote it with torch. We wrote it with torch in Python. We exported it, and now we're trying to load it in Zig. This guy wants a U size of how many elements? This is the size in bytes, as you can tell by the comment that says bytes. So this is IDs, data. This is just token count times size of I64, I guess. Input shape. What is the type of input shape? Which of these, like, 400 tabs was this? Okay. Shape. So where does shape come from here? Oh, okay. It's a list of I64s, but how does he know the size of the shape? Right, because this is just a pointer in his world. Maybe it's like 0 terminated? What is rank? Maybe rank is the number of dimensions. Yeah, I see. That is the number of dimensions. So we know that we have 2 dimensions, and we know our dims is going to be, I guess he wanted a list of I64s, right? So he wanted, like, 2 I64, or because was he casting to side? Yeah, he's got N64 shape. Yeah, so this has to be 2 I64 is going to be 1 by token count. Okay, 1 batch of token count size. Okay, so this is dims now, like this. By 2, we set the type here. So here we want to set the data type as onnx tensor element data type int 64, I guess. And then we put this to IDs. Okay. Like this, maybe? Try C check, probably? Okay, that builds. And runs. It's a good sign. So now we want to do this for the other guy as well, right? So I wonder if we want to wrap this in some way. We probably will later, but for now, let's just kind of copy paste. Fix me, lol, this is identical to above, but fuck off, you know? So this is going to be the attention data. Mask data, this is mask. Mask data, dims is the same because the dimensions of the mask is the same as the input tokens. We use mask here. And then we should be able to just fucking run this bad boy now that we have the shit. I guess we need a list of ORT value pointers, but that's okay. I think this is fine. Okay. Gort run, but with a question mark. We have our session. I don't know what this is. Can we look at the ORT runtime run? What is this? ORT onnx onnx. Oh, we should just fucking look at where was it? This one. Run. Hello? Run. How is run not in? Oh, because maybe it's like defined as, here we go. Fucking macros, man. Oh, we just have run options null? Fuck it. Sure. I'm down. Inputs name list. Do we need to name them? Like, can I just not use indexes? Of null. Yeah. I just want to use indexes. I'm not a dumb piece of shit, you know what I mean? So this is going to be like ID's mask, I think. I guess maybe we should be a little bit more like, this might not work. Input count 2. Output count is going to be 2 tensors, I think, as well. Right, we saw that we return 1 output that was the batch of date guesses, and then the other one was the batch of classification. So I think this is also 2. And then, so I guess we need, like, outputs is going to be 2 ORT values, pointers, null at first. Whoa, hold on. Output tensor. Wait, I'm missing something. It was output names len. Oh, we just do null 0, right? Yeah. I don't give a fuck about the names. We'll figure. We know what they are. Again, we're not stupid. So null. Wait. Null 0. Output tensor. So our output tensor is a single ORT value, I guess. Like this. Like this. So something like that, maybe? And then, can we print the shape of this thing? Like, how the fuck do I get the shape? We have the API somewhere. Shape. ORT, tensor, and shape info. Cast type info tensor info. Create tensor and shape info. Get dimensions count. Get dimensions. This is probably what we're looking for, right? So we have input of ORT tensor type and shape info. But like, how do I make an info? You know what I mean? This is a like I want value to type info. So maybe I'm looking for like type info dot star value. Get type info. Perfect. Get type information of an ORT value. Okay. Get value type. Oh, perfect. Do I have a get value shape or anything? Get value dimensions. No. Okay. So I guess we want type info, then shape. Count sounds close. Let's see what this says. So what does this return? This returns an ORT status. Sure. So we need to put the outputs as out is a pointer to U size. Okay, sure. Outs puts size. All right. Let's see what happens. Let's see what happens. What's he pissed about? True. No splatting here. This is not okay. Sure. So we need inputs is going to be 2 pointers to see ORT values. I'm a little confused actually about how outputs can be a single tensor, because like the 2 outputs could have different types. So that's a little odd to me, but we'll see where this goes. Core dumped. Perfect. That's what I love to see, baby. I guess we need to pull open the debugger, see where the fuck we're going wrong. Run model, use LVM true so that we can GDB without problems. Where are we going? Where are we going? Oh my god, I don't have GDB installed. Fuck you. Fuck you! Alright. Run that bitch, please. Go! Go, go, go. Oh my god, he has to download debug info. Hurry up, God, please. Please. Is this riveting content? Is this riveting content? Absolutely. It's not even doing anything. Kill all GDB. Kill all GDB. Kill all -9 GDB. Can we run it again? Does it just running the second time like make it work? I'm at the edge of my seat right now. Yeah, dude, like what is happening? Nothing is happening. Fuck my life. We'll just kind of leave that for a bit, I guess. We'll see if he gets up to anything. We'll see. But until then, we will try to debug our own way. What are we looking for? Run model. Here, we'll just kind of do this. So presumably someone's just dereferencing a null, right? Surely. If true, return. We'll just bisect, I guess. Dude, fuck running this shit with LVM. Let's go fast mode zoom zoom, you know? Okay, that did not crash. We're bisecting. We're bisecting. Don't worry about me. Oh! Oh! Something happened up there? Are we crashing on run? Yes. Okay, so which one of these guys isn't allowed to be null then, huh? That's not helpful. It's not helpful at all. Alright, well. This guy wants run options, which were null in the example. Input names, null. Inputs is this. Input len is 2. Oh, so maybe the names. Maybe this, like, input len requires. He's, like, indexing into the input names list, which he doesn't like. So maybe we need, like, input names. Maybe we need to do, like, this. You know what I mean? Like, I don't know if that will cast correctly. I don't know, like, the rules here. So I'm gonna do this. Okay, that's better. That is definitely better. We can close this terminal. We don't need it anymore. Okay. Can we print that guy's example had error message logging? So let's kind of see if he tells us anything of value here. Gort. Okay, status, stood, debug, print, gort error, got error. I guess we'll leave it. That's also sane. Input names cannot be empty. I guess, you know, if you say so. What were our names? Input IDs and attention mask. So I think if I'm like 2 sentinel terminated U8 strings, feels like that should work. So this is input IDs and attention mask. And this just needs like a little pointer cast. No big dealio. Got null input supplied for input IDs. I guess my inputs are null, huh? When you say it like that, it sounds fucking stupid. Okay, now we're segfaulting at address 0. That's beautiful. Love that. Maybe because we need to specify output names? That, or if we got like the input names types wrong here. That's also possible. Let's just give output names. So what are our output names? Did we see them somewhere when we like exported the model? Output. This is not helpful. This is not helpful. Somewhere we like ran export model. Export pi. Then what did he say? Up here. Up here. Somewhere he's got to tell me what the output names are. Linear 37 and linear 38. Beautiful names. Absolutely beautiful names. Linear 37, linear 38. Thank you. That is perfect. All right. Well, on the bright side, that wasn't it. On the not so bright side, I'm worried about the input names type now. Maybe change to pointer consuate. Yeah, I am worried about the type there for sure. At least one output should be requested. Yeah, nice. Thank you. Good eye. Good eye. Looks like he wants linear 37 and linear 38 here. It's crazy. Got unexpected output data type. Actual in 64. Expected TensorFlow. My outputs are unexpected output data type. But my output data type is not defined anywhere, right? My output is ORT value. Do I have to initialize the output somehow? I guess, right, so this is what I was fucking talking about, huh? Was that, like, the two types of the outputs are different. The first dimension of the outputs is, the... No, they should be, no, they should be both floats. They should both be floats. So who the fuck is saying that my output data type is an int64? Because, like, the only thing I've defined for outputs here is, like, this. I'm like, here's null, bitch. Maybe, let's just double check the... something. Not sure what I want to double check. We should double check something. Can we, like, get the output information? Or, like, what does this guy do, I guess, when he runs out? His output tensor is just null here. He does call run to get the output tensor. Yeah, so there's nothing crazy there. Oh, this is what I was looking for, by the way. Get type or tensor type and shape. Can we double check? Can we double check what our model was exporting? Too long. And then what is our, like, model? Like, our outputs are token logits and medium logits, which are both just floats, I think. Yeah, those are just floats. So I don't know whose long he's mad about. We could try saying floats here. It just doesn't sound right to me. But, like, maybe he wants these things cast to floats before they go in. Doesn't sound right to me, but that's the only place where int64s are even coming into the equation. You know what I mean? No, okay, so unexpected input data type. He's like, I want an int64. That makes sense to me, right? So he is just mad about the output types. But it's just like we don't define the output types at all. You know what I mean? I suspect that maybe the output names that we've picked are wrong. That's the only, like, okay, what if we only pick one? You know what I mean? Give me one guy. You know, just give me one of them. Oh, okay. Input is not of type sequence or map. Yeah, so it was get tensor type and shape. This is the function we wanted, which has ORT type and shape info. Please tell me that this is like a struct that it's a fucking opaque struct. Fuck my life. Okay. Get value count. Input is not of type sequence or map. Okay, well. So if I switch this to linear 38, does he also get mad, by the way? Yeah, I mean, yeah, it's weird that we like can't mix and match them. Can we name the outputs on export so that this is less confusing? I would love to name my outputs. So how the fuck do we export this? Example inputs, onnx export. Can we name our outputs? Output names, we can. So let's do that so that just to like reduce confusion. So here we go like output names is we have two of them. So it's gonna be bios and mediums, I guess is what we'll call them. I think that is fine names for these things. Great, let's try that. This guy Gord is a pain, right? Yeah, Gord is annoying us for sure. He's being a big pain in our ass. So now we should be able to here, instead of saying like linear 38, like, I already forgot what we called them. Bios and mediums, I think is what we called them. Well, let's just do bios. I guess just one of them. Okay. Cool. And then, okay, so if I do bios and mediums together now, which should have similar types now, can I do both of them? Yeah, that's just so weird. I feel like the outputs are wrong. That's how I'm feeling right now, is like, I'm saying like, hey, give me a tensor of like 2 sets of floating point pieces of information. No, it still doesn't make sense, because even then, the two outputs have like different dimensions. So you can't express that in like one tensor. Can we look up like onnx? Maybe we ask the idiot here. Maybe we ask the idiot. My output tensors. Oh, that's interesting. He is allocating a list of 2 ORT values. Oh, so maybe this is supposed to be like this when we do it this way. And then maybe he was looking at undefined memory and seeing that the ORT value existed, and he didn't like that. You know what I mean? Ah, yes, okay, that makes more sense. That makes much more sense to me. Fuck yes, dude. All right. So now, I don't know what we're trying to do here. We're trying to like get the shapes of the outputs, which he's calling get tensor type of shape. I guess we'll just fucking, well, fuck you. I'm not mad, you're mad. Okay, so we have this var output shape info is this, one of these, he's got one of these, one of these. He's a Gort, hit me with, tell me what it's about, bro, please. Uh-huh. We need to say, but like maybe I'm not sure. Hit a little question mark in there. We have var out dims. Hit me with it, Gord. Yeah. This is just a U size, I think. Great. Like this. Make him look a little unsure. Beautiful. And then. Oh, we know the dimension. Yeah, I guess we don't know. Out num dims. All right. And then here, I guess let's just print that for a second, and we'll come back to the rest later. Alright, try C-check this guy, because we need to fail on failure. So true. Too few arguments, shut the fuck up. We will actually pass the thing then, if you're gonna be so picky about it. Auto mods banning people saying Gort, that's pretty funny. Cool, 3 dimensions, that is what I expected. 4 outputs. Output, let's kind of log some information about these things. Let's try to get the dimensions. Out, dims, I64, 0. Slap that shit. I guess we want 3. I guess we'll do 3 and we'll say if out num dims is greater than 3, we will return error too many dims, because we're kind of expressing them on the stack. Fuck it, I don't want to alloc. Gort's gonna tell me who those dimensions are. Like this. I guess that's fine. We'll say dims is maybe out dims from 0 to out num dims, and we just kind of let that ride, I guess. Sure. And we probably want this to run on output, not output 0. Oh, right. Fuck my life. Infiled format string. Any? Any. There you go. Boom! There are 2 outputs. Holy shit. Holy shit. Dude, this is so much work. This is so much more work than I imagined. Okay, we got our fucking dimensions. Can we get the fucking data now? Oh my lord. Where's the data? Okay, how do we fucking yoinkies the data out of this thing? Get tensor mutable data assumes float output. I guess we should like theoretically check the type, huh? Like get type info. Who gives us back an ORT type info? Please tell me that this is wait, get tensor shape element, get tensor type and shape. One of these guys. Please, God, tell me the type. No? None of these are gonna tell me this thing is... Oh, it's opaque. Yeah, of fucking course it is. So there's get dimensions on the type and shape info. Are you telling me that in the ORT tensor type and shape info, I can't get the type? Are you telling me I can't get the fucking type? There's no way, right? Create tensor type, sparse type, set dimensions, get tensor element type. Oh, here's the one. Thank you. Okay, get tensor element type. Okay, and then please tell me this is something that I can inspect. Oh, thank God. Okay, get tensor element type. Get tensor element type. Get tensor element type. We have to get the tensor element type. So this is, we sure, element type. Get tensor element type. I don't know why, how, element. Thank God. Okay, what's he take? He takes a U32 or something as the output. Var element type is, C, was it onnx tensor, what is this thing? It's onnx tensor element data type. Onnx tensor element data type. Onnx tensor element data. There we go. Oh my God. Onnx element type. If element type is not equal to onnx tensor type float, return error, incorrect type. Please everything be floats. Please God, everything be floats. Thank God. Okay. Okay, so now we can call get tensor mutable data. Boom, boom, boom. Var data is going to be some multi-element pointer to F32s is null. Is it like this? Is this allowed? Please, God, give me the data. Gort, please, for the love of fucking God, give me the data. So 4, maybe we'll just look at the first number of elements. So in out dims 2. Can we just print this? Data at I. Please, God. He doesn't like this because he's like, I wanted a pointer to any opaque. I'm hoping that doing like the nullable slice thing works the same as with a single element pointer. I'm not positive on that, but I think it does. Expected use size, int cast here, fuck you, fuck you. All right. I think those numbers look familiar, by the way, which is a very good sign, right? I think these numbers look familiar. Because I think that I remember seeing a 1.37 when we were running ones through the model earlier, right? Yeah, right? So this is really promising in that these numbers are the same numbers, which means that when we run ones through the model, we get the same output. That is very good. Very good. So now what we want to do is we want to actually like run it on real data. The numbers, what do they mean? This means this is the these are like how is this? These numbers are the probability that we are outside a date, the beginning of a date, or inside a date. So that's why we call these BIOs. And then these numbers are the probability that we are a home released movie or a theater released movie. So for these guys, we take the maximum. We take the maximum of the 3. This one we evaluate each one independently. If these ones is like greater than 0, I believe means that he thinks that he's this. Inside what date? Right, so we're trying to pull dates out of Wikipedia pages that are home releases DVDs. Negative probabilities. Yeah, I mean, probabilities is the wrong word. These are, I think they're called logits. It's basically like float max is like very positive, and float min is like very, very unlikely. You know what I mean? Or like maybe it's a negative float max. You know what I mean? Negative, like whatever. Okay. So can we please, God, I guess like try to run on a Wikipedia page segment. This is you pass the softmax to get probabilities, right? Well, how do I say this? I think yes. On the first one. On the second one, no. On the second one, you pass it to, like, I think sigmoid or something. Okay. So we have a thing somewhere, right? We have an inputs preprocess no U2F8 under Spider-Man 2. Under, what was it, like 40 or something? 39? 39 has some DVD release date. So we're going to run on Spider-Man 2 39. Don't let me forget. Spider pre-processed, no UTF-8. We could do the pre-processing in Zig right now, but let's like kind of just limit the amount of like fuckery that we have to handle right now because we're already over time. This is going way slower than I thought it would. const input is this thing. Embed file. Fuck it. Can we do that? Is that gonna let us do that? And then can we say like tokenize get tokens? Which I guess we have a maximum of 512, so we'll just say token buff right now because I'm fucking lazy. Which we said we're I64s, right? If I remember correctly. Something like this. Maybe we'll take the token buff here. Just to be a little bit better citizens of the world. Okay. And we will return some I64s. Cool. Then we go, I think we have a tokenizer. And we should just be able to be like, wow, like var tokenizer is tokenizer init. He needs some allocators. Of course he does. Because we did correct API design. Arena expansion. Fine. Fine, we'll fucking make you some allocators. Fine. 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 Cool. Wow, tokenizer. Next. Tokenize. This guy just gives me the fucking thing. Okay, cool. He gives us back his use sizes though, which is funny. I wonder if I can feed it in another data type. No, they said, how do I say this? The input thing was checking type, so he doesn't do like an autocast or anything. So if we want I64s here, unfortunately, I guess we just change this tokenizer output to be I64. That just solves the problem. Because, like, what is this tokenizer for if not to feed us? You know what I mean? Like, what are we fucking talking about? This is for us, so we can specify whatever we want here. Okay, we need to tokenize some input text. Okay. Vocab needs to map then to I64s. Which means that, like, ret here needs to be a map to I64s, which means that this thing needs to be an cast index. I think everything else is fine. Tokenized here, hues, like, test, I64, which means expected needs to also come in I64 form, which means that this guy needs to be I64 here. And this guy needs to be I64 here. There we go. Cool, everyone's happy. So get tokens, we just return this thing. And then here we do like IDs data when we construct this thing is get tokens. Okay. Var arenas stood heap arena allocator initialize the stood heap page allocator. I really do not give a fuck right now. I'm like, I really just can't. I cannot be asked. I cannot be asked. A bird told me that you used to develop firmware cameras. Is that correct? It is correct. I did used to do that. True dat. Okay. So this thing is like tokenized. So this is going to be ID's data len here. And then this is ID's data len times I64 size. Great. This guy cannot be... This guy's like variable now, so our mask data has to be a like, I guess it's like a allocator, runtime allocated slice of I64s again, but of size ID's data len here, and then we just splat in ones, I think. So we just do, I guess it's a mem set. Yeah, like this. And then token count is mask data len here. Beautiful. Then everything else should just work. He can't embed a file outside the path. Fuck my life. We'll just copy paste it. I don't give a fuck. Inputs, preprocessed, no UTF-8, Spider-Man 2, 39 dot. Fuck you. IDs, data, oh my god. This needs to be int cast here because he wants to be I64, so true. Did I not save? There we go. Expected any opaque found const I64. Maybe I need to do IDs data dot pointer now instead of a pointer. Yes. It's like this now. Okay. Promising. And then can we then try to extract the actual source text where something happened? So what we're supposed to do is we're supposed to loop over all of the data that came out of this thing. I guess like only for output 0. So I think all of this code needs to turn into like a function that returns a slice of F32s and its dimensions. I think. Like get output, right? And this is going to return like a float like this. And then maybe we don't even bother doing like shaping of it because we can kind of derive the shape that we expected this thing to be based off of the inputs that we gave it. I think that makes sense. So this was a ORT value, if I remember correctly. Then all of this just kind of works, and then we should just be able to like return data from 0 to something. I guess it'd be like outdims. I guess it's like var size is outdims 0, and then it's like for size to outnum dims, we like multiply this by something. So we have like, I guess it's out dims size to outnum dims, and we say we just multiply, right? Like dim, say size times equals dim, and then we can do out dims size here. I think it's like something like this, right? So like 0 times 1 times 2, yeah, sure. So then down here we can say at the very bottom, get output for outputs 0. And this should be giving me like BIOs. Which he doesn't like, because I spelled this wrong. There we go. And we should be able to like assert here, or I guess we should be like, if BIOs len is not equal to input, what was it? Data, IDs data len times 3, return error unexpected. But this is what I expect to see. Yeah, this is not printing anymore. True. And let's just not bother printing here either. This thing needs to be able to fail. True. Good point. Then size here, he's not happy because he is like, that's an I64, dumbass. I need to be a U size, you fucking dumb idiot. So true. Dim here is like, yo, hello. We're like, a good point. And then this is like, you gave me something fucked. Yeah, sure. Dereference that thing. Try here. All right. Great sign. Great sign. This is the format we expect. So we want to go for each input token. We want to like pull out spans. Extract spans here. Yeah. So we have outputs, F32, and then we want like num tokens probably as U size. something like this. And what are we trying to return? Like a list of let's count spans. We'll call this count spans first, or we'll count spans. So like we should find, I think it was 6 outputs, if I remember correctly, when we ran inference on Spider-Man 39. I think we got 6 dates that it found. 1, 2, 3, 4, 5, 6, right? So we should be able to count those 6. So I think it's just like if var count is 0, and if outputs, we need to like chunk the outputs in chunks of 3, right? Because there's like 3 possible classifications for each token: outside the date, beginning a date, or inside the date, right? So we do for 0 to outputs len over 3, I guess, and we kind of like say outputs from I times 3 onwards 0 to 3. This is our like LMs. I don't know what the word for this is. And I think we just want to like take the max, but we don't want the max. We want the maximum index, right? Index of max, right? So this is going to be classification of this thing. And if classification is equal to 1, which I believe is our number for the beginning of text, I could be wrong here. Count plus equals 1 and return count. I think that makes sense. Now, num tokens here is actually implicit, which is interesting. So we'll call this BIOs. I think this is a better term here. Beginning, in, out. And let's say like found this many spans from extract spans BIOs. It should be that easy. It should be that easy. Oh, let's fucking go, baby. That's 6 fucking spans. Let's go. That's the expected answer, baby. And we can actually look at the classifications of those things too. Span classifications. So we can say like these are like mediums. And the mediums are going to be another list of F32s. So we have to get mediums as well. So this is from outputs 1. And this should be the length of the tokens times 2. So we're going to throw this in here now. And I think I'm just going to log inline. I think that's easier. So let's say like if classification is 1, we can say we basically like we only during training checked if we were home or theatrical releases on the beginning of a token. Like so we should check mediums at I times 2 onwards 0 to 2. Your if check after medium still using BIOs len, not mediums. True. That's a good point. So here we should be like home logit is medium classification 0, and the theater logit is this guy. And so what we should see is on all of these guys, according to the original model we ran, all of these guys should be classified as home and not as theater. So we should be like std debug print found date home this number, theater this number. And so what we want to see on all of these is that home is high, like really fucking high, and theater is really fucking low. I believe. Pretty fucking good, man. So I believe that like the data type here, by the way, is every increase in 1 is an increase of a power of 2. So this thing is like approximately 2 to the 9 sure out of all floats. Like probably like 2, like he's like very confident, right? Like 0 is like 50% confident. 2 to the 9 confident is like really fucking good. He's like very, very confident that all of these are related to DVDs and all of these, and they're not related to theater. That's like, this is like very good, consistent signal that indicates that we are doing what we expect we're doing. And so now, I guess what we're missing, by the way, is the tokenized output doesn't tell us what the input text is. However, we can kind of reconstruct it from the tokenizer, which is funny. Because the tokenizer has a list of vocab. So this vocab is a list of string words to integers, but we can kind of go like backwards. So this vocab word is more like, this should be like string to index, maybe, is a better word for this, because our yeah, this should be like string to index. Like, that's just a better word for what this is. Okay, and then we can store the vocab here too, which should just be like a list of strings, right? So at each index in the vocabulary, this should just be like, if you index into this, you get the word that the original string was. You know what I mean? Like, kind of like separated by new line or whatever. So can we load this thing? We have this thing as like a string of new line delimited things. So all we have to do here is say like var vocab is a array list of string segments. Something like this, right? And so we kind of say like vocab put append here. We get the like key is this thing. He could share the allocation. And then we append the key here with our allocator. Easy. And then we say vocab is vocab. And then we should be able to pull the string back out later. So if we like in main or in like run model or whatever, in here, our tokenizer should be created kind of up above a layer now. We're leaking memory like fucking everywhere, by the way. Like all over the place. All over the place. Don't worry about it. And then we don't even need a function for this. Fuck it. IDs, data. Like, it should just be like this, to be honest. Alright. Fuck this function. And then we should be able to kind of use the tokenizer here. Because I wanna say like which word this was, right? So tokenizer, like, I guess we want like the input tokens as well. Right? And we should be able to be like input tokens at this index should be able to like be extracted from the tokenizer. You know what I mean? So we're gonna like look at the vocab at this location, and we're gonna print this. And this should be the first word of a date, ideally. Ideally, if all this works, this should be the first word of a date. That dog is so cute. Thank you. I agree. I also think she's cute. IDs, data, I guess, is what goes in here. And then tokenizer here. Input tokens would be incast here, I guess. This might crash in some way, but I don't give a fuck. Right, so here we see November, 2005, October 2017, which is like a really good sign. And I actually think what we're gonna do here is we're gonna say, we're gonna specify like in span is true here, right? And we'll say in span is false. And we'll say, if classification is 0, we set in span to false. If classification is 1, we set to true. And if it's 2, that's like a span continuation. So we should just be able to like keep fucking printing. You know what I mean? And then maybe we print a new line here or something. Like if in span, we print a new line here. And then I think that kind of makes it so that we should see what the date was. Not fucking bad. Not fucking bad, right? So here we see, November 30th, 2004 was a home release date. November 17th, home release date. November 26th, home release date. 2005, home release date. October 2007, home release date. 2017, home release date. And if we look back to when we ran inference on this thing, wherever the fuck that was, those all match perfectly, right? November 30, 2004, November 17, November 26th, 2005, October 2007. So the difference here is that we are printing, by the way, off the token names. So what's interesting about this is like, this is what the actual input text is, right? But this is what the model sees, right? It sees November 30, 2004. Yeah, I think that's a win. I was gonna do more than this today, but this took way fucking longer than I thought it would. I don't even know like where the pain was. I guess 50 minutes to like export the model was like quite the shock. And then like another hour to like run it. Right? That's 1 hour to export the model, 1 hour to run. And like it's funny. Like when you have a day like today, you can like imagine why you can like see why vibe coding is so fucking popular. Right? Because like what did we do today? Nothing. Right? Like we kind of did, but all of the interesting work was like done already. So like I wonder if like the problem is that the work we did today is all so library slop, I guess you could call it. Right? I often say like the importance of programming by hand is that you need to like gain familiarity with the things that you're using so that you can like figure out you can like reason about them better, I guess, right? But what's interesting about today is all of the ideas were already there. We already knew all of the pieces of what we want, right? We knew that we were going to be constructing some tensors. We are going to be like loading this model. Like the allocation stuff is maybe not like super clear, but like we know that we're just trying to pipe input tensors to output tensors in this format. And I can like, I guess usually I'm like, fuck you for using AI for coding that much, but like this is like a case where I'd kind of be down. And I could see a world where if a lot of professional programming is library slop, which I think it is, then I can maybe start to understand the idea of why people push this stuff so hard. Because this was like just something that would be done in minutes for like zero cost. And instead we just spent 2 hours piping stuff around. Like, which is maybe an indication that like we're doing something wrong, but it's interesting to think about. That's not where I expected this to go, by the way. I did not expect to say at the end of this stream that I like AI slop. But it is what it is. I am happy with this though. This is like really promising, right? This is like a good indication that this idea will work. I think we're like maybe 2 steps away from integrating it with the TV tracker. So, happy with that. I'm happy that this turned out. Cool. All right. If you like what we saw, guys, we stream probably like 3 or 4 times a week. We aim for 12:30 Pacific time. It is 3 o'clock Pacific time now if you're watching live. There's a YouTube channel where this will go up. Sometimes we stream it does not go up on YouTube. It depends on if I think that it's like a titleable, thumbnailable thing, right? The stuff that does not go up on YouTube goes up on Patreon or gets archived on Twitch or gets archived on YouTube member. So if you support the stream in those segments, you are one, helping contribute to the lifetime of the stream as a whole, because, one day I'll run out of money and I'll have to get a job and this will stop. And you get access to the VODs that do not go up. So consider, but obviously no pressure. YouTube, peace. Twitch, let's find someone to raid.